In this video, we're doing a partial fractions integral that's generalized so that we have two linear factors in the denominator, but they're written as x plus a and x plus b. We're told that a is not equal to b. And the reason why is that if a was equal to b, that would be a repeated linear factor and it would change the way we propose our partial fractions decomposition. So we know that these two linear factors are unique and we propose a partial fractions decomposition. And the idea with that is that 1 over the product of these two factors should be decomposable into two simpler fractions, each of which has only one of these factors in its denominator. So a big A over x plus little a and a big B over x plus little b. And then the whole game here is to figure out what the big A and big B are to make this possible. So we start by clearing out all the denominators. We multiply both sides by x plus little a, x plus little b. When we distribute those two factors to the left-hand side, both of them cancel and I have just a 1 over there. When we distribute these two factors to the big A containing term, the x plus little a cancels, but the x plus b does not. And I end up with big A times the quantity x plus little b. And then the opposite thing happens with the big B containing term. The x plus b's cancel, and I'm left with big B times the quantity x plus little a. Now this equation is very quickly solved by using substitution. So we're going to let x equal negative little b. And if I do that, I get 1 on the left-hand side. And notice that the big A containing term is going to vanish because I replaced x with negative little b. This factor is 0. And the only survivor here is big B times negative little b plus a. Note that I could also write that factor as a minus b. So when I solve for my undetermined constant, capital B, I get 1 over a minus b. When I substitute in x equals negative little a, the other term is going to vanish. The second term vanishes instead, and I end up with a 1 on the left-hand side, and then big A times negative little a plus little b. Again, we could write that factor as b minus a, and I end up with large A. My second undetermined constant is 1 over little b minus little a. So there's a nice symmetry to the way these are coming out. And now I can look at my original integral and rewrite it with this partial fractions decomposition. So big A was 1 over b minus a. And in our partial fractions decomposition, big A was in the numerator, x plus little a in the denominator. And then similar for big B. Big B is 1 over the quantity a minus b. And that was the numerator for this second fraction with a denominator of x plus little b and dx. So remember, x is the variable here, and I have some constants divided by this linear term x plus a. That integrates to a natural log of the absolute value of the denominator, and the same thing happens in the second one. So I end up with a 1 over little b minus little a, natural log absolute value x plus a, plus a 1 over a minus b, natural log absolute value x plus little b, plus c. Now there's a bit we can do to simplify this. I can write a minus b as the negative of the quantity b minus a, and that would make these two denominators match, so we could do some factoring. So I'm going to write it like this: 1 over little b minus little a, natural log absolute value x plus little a, minus 1 over b minus a, natural log absolute value x plus little b, plus our arbitrary constant c, and we factor out the 1 over b minus a, leaving us with a natural log absolute value x plus a minus natural log absolute value x plus b plus c. And now we can use log properties because I have a difference of two logs. That's the log of the quotient. And I end up with 1 over little b minus little a, natural log of the absolute value x plus a over x plus b, plus an arbitrary constant c, and we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.